A very important question. dy by dx is equal to sin x plus y plus cos x plus y. Now identifying the function we are having, now let x plus y is equal to z, differentiating with respect to x, 1 plus dy by dx is equal to dz by dx, and this implies dy by dx is equal to dz by dx minus 1. Substituting z and value of dy by dx in equation 1, we get dz by dx minus 1 is equal to sin z plus cos z. This implies dz upon dx is equal to sin z plus cos z plus 1. Now 1 upon sin z plus cos z plus 1 with dz is equal to dx. Integrating both sides, integration of 1 upon sin z plus cos z plus 1 dz is equal to integration of dx. Now putting sin z is equal to 2 tan z by 2 upon 1 plus tan square z by 2, and cos z is equal to 1 minus tan square z by 2 upon 1 plus tan square z by 2. Integration of 1 upon two tan z upon 2 upon 1 plus tan square z upon 2 plus 1 minus tan square z upon 2 upon 1 plus tan square z upon 2 plus 1 dz is equal to integration of dx. Now this becomes, after taking LCM, integration of secant square z upon 2 upon tan z by 2 plus 1 minus tan square z by 2 plus 1 plus tan square z by 2 dz is equal to x plus c. Okay. Now this becomes secant square z by 2 upon 2 tan z by 2 plus 1. This and this is cancelled. Okay. Dz is equal to x plus c. Now let tan z by 2 is equal to t differentiating with respect to z. We are having secant square z by 2 into 1 by 2 dz is equal to dt, or secant square z by 2 dz is equal to 2 dt. Now substituting the values, integration of dt upon t plus 1 is equal to x plus c. This implies log mod of t plus 1 is equal to x plus c. Log t is tan z upon 2 plus 1 is equal to x plus c, and log 1 plus tan x plus y upon 2 is equal to x plus c. This is the answer.